Welcome to Kenton Teaches. Enjoy the video.
You begin by confirming core tools, Python 3, 10 plus pip packages like gym and stable baselines 3. Once done, create a minimal environment wrapper that standardizes observations and actions so your agent sees consistent shapes. Next, seed your RNGs and run a quick reset step loop to verify states and rewards. Then implement a trivial agent, random or rule-based, to validate the full data path. This early check saves time because it isolates env issues before training heavy networks. Now you build the model and training pipeline. Choose an algorithm, DQN for discrete actions, PPO or A2C for on-policy cases, SAC for continuous control. Design a compact neural network, normalize inputs, and set up a replay buffer or advantage estimator as required. Implement the core training loop. Collect transitions, compute losses, apply optimizer steps, and update target networks at fixed intervals. Make sure to log rewards and losses, run periodic evaluations, and save checkpoints. To finish, evaluate thoroughly. Run long validation episodes, compute moving average returns, and visualize agent behavior to detect corner cases. Once satisfied, export the policy and create an inference wrapper that runs deterministically for evaluation and stochastically for exploration during deployment. Make sure to include seed control and version checkpoints. If training diverges or performance stalls, first lower the learning rate and increase batch size. If that fails, clip or normalize rewards and simplify the network. This targeted troubleshooting often recovers training quickly.
Thanks for watching. Please subscribe if this video was helpful.